This lesson covers the takeoff climb performance requirements. The takeoff flight path begins at liftoff and extends to at least 1,500 feet above the runway. There are engine-out climb capability requirements in each of 4 segments. The climb limited weight is calculated at 0 wind conditions. The first segment begins at liftoff and is completed when the gear is fully retracted. The second segment is from the gear up point until the airplane reaches the target level off height. The third segment covers the level flight acceleration and flap retraction. The final segment begins when the flaps have been retracted and the airplane has accelerated to the engine-out final climb speed. To start, let's first define climb gradient. The climb gradient is the ratio of the increase in altitude to the horizontal distance. In this example, the increase in altitude is 240 feet and the horizontal distance covered is 10,000 feet. The climb gradient is 240 divided by 10,000, which equals 0.024. Gradient is normally expressed as a percent. To get percent, multiply the ratio by 100. The climb gradient is proportional to the thrust-to-weight ratio minus drag-to-lift ratio. At the standard V2, the engine-out climb capability equals the minimum required when the airplane is at the maximum climb limited takeoff gross weight. Let's examine the climb gradient requirements in the 4 segments. The first segment extends from liftoff to the gear up point. During the first segment with a single engine failure, the thrust is maintained at the takeoff thrust setting. The gear retraction is initiated when the crew observes a positive rate of climb. From liftoff until the gear is completely retracted, the engine-out climb gradient capability must be positive for a twin-engine airplane and at least 0.5% for a 4-engine airplane. The second segment begins at the gear up point and continues to the level off height. During the engine-out second segment, the thrust is maintained at the takeoff thrust level and the speed is held constant at V2. The engine-out climb capability at the start of the second segment must be at least 2.4% for a 2-engine airplane and 3% for a 4-engine airplane. For a climb gradient of 2.4% at a V2 speed of 164 knots, the airplane will have a rate of climb of 400 feet per minute. Of all of the climb requirements, the second segment engine-out climb gradient is often the most limiting. The third segment begins at the initiation of level flight acceleration. This altitude is called the level off height. The level off height is determined by company policy, the FAR minimum of 400 feet, takeoff thrust time limits, or obstacles. The engine-out climb gradient capability above 400 feet must be at least 1.2% for a 2-engine airplane and 1.7% for a 4-engine airplane. At 1.2%, the rate of climb would be 200 feet per minute at an airspeed of 164 knots. During the third segment, the flaps are retracted to the lower settings as the airplane accelerates through the flap retraction speed schedule. The absolute minimum level-off height, the FAR minimum, is 400 feet above ground level. There is a 5-minute limit on the use of maximum takeoff thrust. An AFM appendix is needed to extend the time limit to 10 minutes. If maximum takeoff thrust is needed to maintain the required gradient capability in the third segment, the 5-minute limit defines the maximum level-off height. If maximum continuous thrust is sufficient to maintain the required gradient, the second segment may be extended beyond this maximum level-off height. This extended second segment can be used to clear obstacles that lie in the third segment. The final segment is the flaps up climb segment. This segment begins when the flap retraction is complete and the airplane has accelerated to final climb speed. The thrust is set to maximum continuous thrust, MCT. The minimum engine-out climb gradient capability is 1.2% in this segment for a 2-engine airplane and 1.7% for a 4-engine airplane. The final segment and the takeoff flight path is complete when all obstacles have been cleared or the airplane has reached a minimum of 1,500 feet above the airport elevation. Any of the climb requirements may limit the maximum takeoff gross weight. If a requirement cannot be met, the takeoff weight must be reduced until the airplane climb performance meets the climb requirements.